What if we could rewrite history or witness the future firsthand? The very notion of time travel has captivated the human imagination for centuries. From H.G. Wells's The Time Machine to the iconic DeLorean in Back to the Future, the idea of traversing time has fueled countless science fiction stories and sparked endless debates. Think about it, the ability to journey through the annals of history, to witness firsthand the signing of the Declaration of Independence or walk among dinosaurs. But is time travel truly within the realm of possibility, or is it destined to remain forever confined to the pages of science fiction? Today we'll delve into the fascinating world of time travel. From the moment we first grasped the concept of time, we're captivated by its enigmatic nature. Time, an invisible force, governs the rhythm of our lives, dictating the cycles of day and night, the changing seasons and the passage of years. It flows relentlessly forward, shaping our lives, leaving its mark on us, and ultimately carrying us along its current. We are but passengers on this journey, often wondering where it will take us next. But what if we could break free from this linear progression? What if the constraints of time were merely an illusion, and we had the power to navigate its currents at will? What if we could navigate the river of time, dipping into its past currents, or riding its rapids into the future? The possibilities are as boundless as our imagination. This fascination has fueled countless stories, myths and legends across cultures and throughout history. From ancient tales of gods and heroes to modern-day science fiction, the concept of time travel has always intrigued us. Science fiction has gifted us with captivating visions of time travel, from the whimsical adventures of Doctor Who, where the Doctor traverses time and space in a blue police box, to the mind-bending paradoxes of Back to the Future, where a DeLorean car becomes a time machine, creating ripples in the fabric of reality. These stories, while fantastical, tap into our deepest desires and anxieties about time, prompting us to ponder the profound implications of tampering with its delicate fabric. They challenge us to think about the consequences of our actions and the interconnectedness of past, present and future. Imagine standing on the sidelines as history unfolds, witnessing the rise and fall of empires, the birth of civilizations, and the pivotal moments that have shaped our world. Or traveling to distant galaxies where time and space themselves bend to new rules. The mysteries of the cosmos beckon us, inviting us to explore the unknown. The very notion of time travel ignites our imaginations, pushing us to contemplate the vastness of the universe and our place within its grand tapestry. It encourages us to dream big and to question the limits of our reality. But the allure of time travel extends far beyond mere escapism. It offers a profound reflection on our existence, our choices, and the legacy we leave behind. Now, let's shift gears from the realm of imagination to the realm of physics. Time travel has long been a staple of science fiction, but what does science itself have to say about it? Can we ground this captivating concept of time travel in scientific reality? Is it merely a flight of fancy, or is there a kernel of truth to it? Well, the universe is a strange and wondrous place, and our understanding of it is constantly evolving. The more we learn, the more we realize how much we don't know. One of the most revolutionary breakthroughs in modern physics came from a patent clerk named Albert Einstein. His insights changed the way we perceive the very fabric of reality. His theory of relativity, particularly special relativity, threw our Newtonian understanding of a static, universal time for a loop. It was a paradigm shift that opened up new possibilities. Einstein showed us that time is not absolute, but rather relative. This means that time can stretch and contract depending on various factors. Imagine this: time is like a river, flowing at different speeds depending on where you are and how fast you're moving. This analogy helps us grasp the concept of time dilation. This is the essence of time dilation. It's a fascinating phenomenon that has been confirmed through various experiments. The faster you travel through space, the slower time passes for you relative to someone standing still. This effect becomes more pronounced as you approach the speed of light. It's like that twin paradox you may have heard of. This thought experiment illustrates the effects of time dilation in a very tangible way. One twin hops on a spaceship and zips around the cosmos at near light speed, while the other stays put on Earth. The difference in their experiences of time is profound. When the spacefaring twin returns, They've aged less than their earthbound sibling. This isn't just a thought experiment. It's been experimentally verified with atomic clocks. This isn't just a thought experiment. It's been experimentally verified with atomic clocks. These precise instruments have shown that time dilation is a real effect. But what does this have to do with traveling to the past or future? How can we leverage this knowledge to move through time in ways that seem like science fiction? Well, if we could somehow accelerate to speeds approaching the speed of light, we could theoretically slingshot ourselves into the future. This is forward time travel, and while technologically challenging, it's not considered impossible within the framework of known physics. This is forward time travel, and while technologically challenging, it's not considered impossible within the framework of known physics. The real challenge lies in the engineering and energy requirements. Traveling to the past, however, is a whole different ballgame. This is where things get really weird and where we venture into the realm of hypothetical objects like wormholes. This is where things get really weird and where we venture into the realm of hypothetical objects like wormholes. These theoretical passages could connect distant points in space-time. Imagine space-time as a sheet of paper. A wormhole would be like folding that paper so two distant points touch, creating a shortcut through the fabric of space-time itself. This concept, while speculative, opens up intriguing possibilities for time travel. Let's say, just for a moment, that we crack the code of time travel. What then? What happens when we, a species that struggles to manage its own checkbook, gains dominion over the very fabric of time? The ramifications are as profound as they are potentially disastrous. Imagine the historical revisionism. No longer confined to dusty archives and biased accounts, history could become a malleable playground for the highest bidder or the most ruthless ideologue. What's to stop someone from going back and erasing entire civilizations, altering the course of wars, or even preventing the birth of influential figures? The very foundation of our understanding of the past, of cause and effect, would crumble. Could we even comprehend a world where history is constantly being rewritten, where the present is merely a fleeting echo of an ever-shifting past? And what about the social fabric of our society? Imagine the chaos if people could escape their past mistakes, relive their glory days, or exploit future knowledge for personal gain. The very concepts of justice, accountability, and even personal growth would be thrown into disarray. The ethical dilemmas are staggering. So, after that whirlwind tour of the mind-bending possibilities and perilous pitfalls, let's return to our initial question: is time travel actually possible? It's a question that has fascinated humanity for generations, inspiring countless books, movies, and scientific debates. Well, as a scientist, I'm obligated to tell you that right now it's firmly in the realm of speculation. But that doesn't mean we should dismiss it outright. After all, many scientific breakthroughs started as mere speculation. But what's science without a healthy dose of speculation, right? It's this very curiosity and willingness to explore the unknown that drives scientific progress. While we haven't built a working time machine, yet there are areas of active research that keep the dream alive. Scientists are constantly pushing the boundaries of what we know and exploring new frontiers. For example, physicists are hard at work trying to create and manipulate those elusive wormholes in the lab. These theoretical passages through space-time could one day make time travel a reality. Now, these are microscopic wormholes, mind you, but it's a start. Every great journey begins with a single step, and this could be ours. Then there's the study of exotic matter, theoretical stuff with negative mass that could potentially stabilize a wormhole and prevent it from collapsing in on itself. This exotic matter is like the glue that could hold our time travel dreams together. Think of it like the scaffolding that holds the wormhole open for us to travel through. Without it, the structure would simply collapse. And let's not forget about quantum entanglement, that spooky action at a distance where two entangled particles influence each other instantaneously, regardless of the distance between them. This phenomenon could revolutionize our understanding of time and space. Could this bizarre quantum connection hold the key to sending information, or even ourselves, through time? It's a tantalizing possibility that scientists are eager to explore further. These are concepts that push the very boundaries of our understanding of the universe. As we continue to explore and learn, who knows what incredible discoveries await us in the future. As we've journeyed through the cosmos of time travel, exploring its allure, its scientific plausibility, and its profound implications, one thing remains clear. The human fascination with time is as boundless as the universe itself. We are, after all, creatures of time. Our lives are defined by its passage, marked by milestones that etch themselves into the fabric of our memories. But what if we could reach out and touch those memories, relive those moments, or even rewrite those chapters in our personal histories? The allure of time travel lies not just in its potential for adventure or the acquisition of knowledge, but in its profound power to reshape our understanding of ourselves and our place in the grand tapestry of existence. It forces us to confront fundamental questions about free will, destiny, and the very nature of reality itself. So keep exploring, keep questioning, and never lose that childlike sense of awe and curiosity about the universe and our place within it. So, is time travel real? As Carl Sagan once said, extraordinary claims require extraordinary evidence. And right now, the evidence for time travel is more science fiction than science fact. But that doesn't mean we should stop exploring the possibilities. Remember, the universe is under no obligation to make sense to us. Who knows, maybe someday, centuries or even millennia from now, our descendants will look back at our primitive attempts to understand time travel with the same amusement we reserve for ancient maps that warned of sea monsters and the edge of the world.